So here we have another question. It says two charges Q and 2Q are placed along the x-axis in front of a grounded infinite conducting plane as shown in the figure. So we have this figure over here showing the configuration of charges. They are located at a distance of 0.5 meter and 1.5 meter respectively from the plane. The force acting on the charge Q is, we need to find out the force acting on the charge Q. So this is the charge Q placed over here. And this Q is 0.5 meters from the infinite grounded plane. So this is the infinite plane which is grounded. And then 2Q is placed 1.5 meters from the infinite grounded plane. And this horizontal direction right here is the x-axis that we have. And we need to find out the force on the charge Q. Now, this question we can solve by the method of image charges. So, using the method of image charges, we can redraw this configuration as an equivalent configuration. So, the method of image charges says that if you have the infinite plane, so this is the location of, let us call this as the origin. So this is our origin over here, and this is the x-axis. So if we have the origin over here, then we have Q, this is the origin, we have Q placed at 0.5 meters, we have 2Q placed somewhere over here at 1.5 meters, and this is the location of our infinite grounded conducting plane. So the method of image charges says that if you have the infinite grounded conducting plane, you simply reflect your charge configuration about the axis, about the plane. So the plane is like the mirror plane that you have, and you simply reflect your charge configuration. So if we have Q over here, then we would have an image charge corresponding to Q as minus Q, exactly at the same distance but behind the conducting plane. And then we would have minus 2Q as the image charge of Q. So let me use some different colors to make sure which one is image charge of which configuration. So this is for Q, then we have for 2Q. So this minus Q is image charge for Q, minus 2Q is the image charge of 2Q. So either we can work with this configuration which is given as the infinite conducting plane and the charge configuration given, or we can use this equivalent figure. Equivalent. So this configuration can be written as an equivalent diagram over here only for the case x greater than 0. So only in this region. So only in the region, in the positive x region. In the negative x region, you cannot use this charge configuration that we have created by the method of image charges to find out stuff in the x less than 0 domain. So only in the positive x domain, we can replace this infinite grounded conducting plane by this charge configuration to solve the basically force or electric field or potential in the domain where x is greater than 0. So in this domain. And why this image charge configuration works? Well, because this image charge configuration that we have along with this charge configuration that we have on the right hand side, so the right hand side and left hand side charge configurations give us the potential V equal to 0 along the plane situated at the origin and perpendicular to the x-axis. So because of this grounding, we know that infinite grounded conducting plane means that potential of the plane is 0. And using this kind of minus 2q minus q plus 2q kind of charge configuration, you are able to replicate that situation of having potential equal to 0 along that plane. So that's why we can replace this conducting plane by this charge configuration to simplify our basically simplify our problem. But it only works in the positive x direction. You cannot use this configuration to find out stuff in the negative x direction. So let us now find out the force. So force, so this is, this is v equal to 0. So force acting on this q charge would be due to 2q right here, 2q on this side. So this is force due to 2q. Since it's both these charges are of the same sign, so that's the direction of the force, it will repel. Then we have force due to this minus q. So we have this force due to minus q, and this minus q will try to attract plus q because these are opposite signs. So again we have this direction, that is negative x direction, and then we have force due to minus 2q. Again, so all these three forces act in the negative x direction over here, and we can simply use the Coulomb's law to write down the force. By the way, these distances are, let me write down, 0.5 meters. This is also 0.5 meters. This right here is 1.5 meters, and this is also 1.5 meters. So let us write down the force. So force acting on q is force due to 2q plus force due to minus q plus force due to minus 2q, and all of this is acting in the negative x direction. So resultant is also in negative x direction. And by Coulomb's law, we have the force, which is q over 4 pi epsilon naught times force due to 2q would be 2q divided by r squared. So r is the distance between q and 2q, and that would be 1.5 meters minus 0.5 meters. So that is 1 meter. So r squared, that is 1 square. Then due to minus q, so that would be q divided by, now the distance is again 0.5 meters plus 0.5 meters, that is 1 squared. Notice that I have not put the minus sign because that takes care of the direction. So once I know which direction, then I can just use the magnitude. So I know that all of these are acting in the negative x direction. So that I've already specified over here. So I'm just writing the magnitude over here. And then due to minus 2q, that is 2q divided by, so the distance is 1.5 meters plus 0.5 meters, that is 2 squared. So we can simplify q over 4 pi epsilon naught. Again, notice that I did not write minus 2q because minus sign takes care of the direction of the force, which we have already specified as negative x direction. So q over 4 pi epsilon naught times 2q plus q plus q by 2. And that is nothing but q over 4 pi epsilon naught 7q over 2. So 7q squared over 4 pi epsilon naught into 2. So the correct option is option number A. So that's the correct answer.